Welcome back. Once again, my name is Spencer. I am a fourth-year medical student here at Columbia and graduating in the class of 2023. This is the third video in our series where we'll be talking about packages in R. So R packages are extensions to the underlying R statistical programming language. These packages contain code, data, and documentation in a standardized format so that they can be installed by users of R anywhere in the world. This helps us get access to lots of resources around the world to make our coding lives easier. We don't have to reinvent the wheel because people have already coded all of the things that we might need. So to see the list of packages you've already installed in your system, you can use the following command, installed.packages. If I run this command, I can see a list of every package that comes built in to the server. We will control which packages are already installed, so you won't have to worry about this during the course. But just to give you an idea of everything that you could access, you can check install.packages. Even if a package is installed, you have to load it into your code so that the server knows to use it. It would take up way too many resources and too much memory on your computer or on the server to have every package from around the world working all at the same time. To load a package, you can use the library command. So here I use the library command to load in the package ggplot2, which I'll talk about briefly later in this video. As I said before, we're going to provide you with all the packages you need for this course, but just so you know, there are millions out there. We will restrict your ability to install packages into Jupyter Notebooks, but if you have your own local installation of R, whether it's in your own Jupyter Notebooks installation on your computer or something like RStudio, you can install packages that you wish to use. If you wish to install a package in that setting, you can use the following command with the package title you desire, install.packages, and then I can put in the name of the package just like that. You will not have to do that for this course, but again, it's a useful thing to be aware of. For the rest of this video, I'm just going to showcase a couple of the highly useful R packages you may encounter in the future and throughout this course. Probably one of the most used packages in R around the world is called the tidyverse package. This package is an umbrella package that has a lot of other packages built into it that include tidyr, dplyr, I'm not sure how to say it out loud, and several other useful packages that help with data analysis, visualization, and other things like ggplot2, tibble, and more. dplyr, which is how I usually say it, is one of the packages in the tidyverse that allows us to manipulate data in a more readable way than the native R package. As I showed before, I can use the library command to load those libraries and packages into my current coding environment. Here you can see it attached all of these sub-packages and that some of these packages overlap with commands, and so sometimes there will be conflicts. I'm going to load in a data set right now to show you some of the benefits of the tidyverse package. You'll learn a lot more about importing data sets in the fourth video. For now, I'm going to load in data on health outcomes at the county level across the United States in the past 10 years. I'll also subset it, as you'll learn in future videos, to only look at counties and to exclude state-level data. If I load that in, here you can see that I have now loaded in a data set that has a variety of different variables as columns and a lot of rows as observations, where each row corresponds to a different county. The following command tells R to create a table that first groups by state and then counts how many observations or counties there are in each of those states. So I have my data frame, which I've defined above as counties df. I use this piping operator, which is the %sign, the greater than sign, the %sign. That tells tidyverse that you're working with its commands. I say I want to group by state, which is the column that I want to make groups by. And then I say what I want it to actually do once it's grouped by. Well, I want it to summarize, which is another command. And the data I want it to specifically summarize is the count based on the number of n rows in each of these groups by state. This may seem confusing, but if you get used to working in tidyverse, you'll get more comfortable with it. So when I run this whole command, I now can see how many counties are in this data set for each state. You can see that Alabama has 67 counties, Alaska 29, so on and so forth. Here's another example of a common tidyverse command, which is creating a new column or new variable. So here I have my county's data frame. I'm saying, okay, with the county's data frame, I want you to use the piping operator, and I want you to mutate a column. I want you to create a new column called number.smokers, which is defined as, using this equal sign, percent smokers, which is a variable already in my data set, times the population, and divide it by 100 because the percent smokers was as a number, not as a decimal. When I do this, it'll create my actual column and label it as number.smokers. Now, to show you that I did this, I will also run a tidyverse command where I will visualize this column. Here you can see I, for every county, have now created the number of smokers that we estimate in each of those counties. Due to rounding, these are not whole numbers, but I can assure you that this is how it would have correctly been done. If I want to see some summary materials, I can use the built-in R command summary to actually get an idea of what the number of smokers looks like across counties. Here you can see in some counties, there are only 10 smokers. This might be in a very unpopulated area. In other counties, there are 800,000 smokers. This would be in a place like New York City. Another really useful package is the ggplot2 package. This is built into tidyverse, and this package is the gold standard for visualization. You can do all sorts of plots with this. You can customize them in a million ways, changing the sizes of the text, the different plots. You can change the colors, you can change the angles, all sorts of things you would want to do, you would use with ggplot2. Most research papers that have really fancy looking plots in academic journals use ggplot2 to generate them. Here, I'm going to load in the ggplot2 package, and I'm going to, just for now, create a subset of counties for just the northeast of the United States, and I only want to include those counties for my visualizations. So for now, I will run those commands. And here I'm going to demonstrate a really cool violin plot. Violin plots are similar to histograms, which you'll learn about later, which just show the distribution of some sort of variable across another dimension. Here, I'm going to show you the percent of people in either fair or poor health in only the counties and states that I've specified above. So if I run this command, I can see that in Connecticut, there are maybe fewer people who are in poor or fair health across all these counties than in a place like Pennsylvania, where I can see that it shifted a little higher in the percent of people in poor or fair health. All of the things in this plot are customizable using ggplot2, whether it's how I would have angled this so they didn't overlap, the sizes of them, as well as the colors. I can also do scatter plots in really, really beautiful ways in ggplot2 that go beyond what you can do with basic R. Here, I'm going to do a scatter plot where I will look at the Y variable, which again is the percent of poor or fair health in a county, and I will compare it to my X variable, which is the percent of uninsured patients in that county. When I generate that plot, you can see that there is a trend where more uninsured people is associated with a higher number of people who are in poor or fair health. I've customized this to change all of the states to different colors, so you can look for clustering based on that. I also made the sizes of the dots be relative to the number of people that are actually in those locations. All of these things are customizable in very simple ways with ggplot2. So for now, all we want you to do is try out opening a notebook and running the command install.packages to see what packages are preloaded into your system. If you can do that, you understand how packages work in the R environment.